Sampling is a powerful statistical tool. It allows us to analyze portions of large datasets rapidly, when the rest of the data is not available, or is computationally too expensive to review. Confidence intervals are a common way to show how certain we can be about any value. Each confidence interval summarizes a distribution as a single bar, showing where 95% of the values are likely to fall. Unfortunately, it can be very difficult to carry out basic tasks, like comparing bars to each other. In this chart, we are seeing estimates of total sales for a store based on samples for 4 different time periods. How likely is it that the 1993 bar has a lower value than the 1995 bar? This problem is even more visible with progressive sampling, in which we look at increasingly sized samples. In this paper, we introduce tools that allow users to quantify uncertainty for specific tasks. The first task is comparing a bar to a constant. The user can interactively choose a value. The system maps the colors of the bars to the probability that the bar's value is greater than the line. Dark red bars are definitely higher, dark blue bars are definitely lower, and white bars are ambiguous. We can also check which bars are within a range. The user now selects the position and size of the range. Dark bars are most likely to be within the range, lighter bars are likely to fall out of it. We can compare one bar to the others. We select this bar, which is highlighted with a dotted line. The other bars are colored by a probability that they are larger than the selected bar. We can identify the minimum and maximum values in the chart. The pie charts show the probability that each bar will be the highest or lowest value. In this case, we can be fairly certain that the purple bar for 1995 is going to be the highest. The lowest bar is more ambiguous. While 1992 is likely, 1994 is also possible. The sort tool visualizes the ranks of distributions. In this chart, we know the highest bar will be 1995. 1993 is likely to be second, but 1994 is a contender. We redundantly map color, height, and width to certainty. This visualization is also useful for the top case scenario, when we might have hundreds or thousands of values and only want to know what items are likely to fall in the top 10. Here, we merge rows 1 to 3 to show the odds of each item falling within the top 3. These visualizations were designed to work in progressive scenarios too. As we read through a large file, we can watch the probabilities converge in any visualization. Smooth animation allows the user to track changes between values. The sort tool cushions the shock of changes in rank by showing how values converge. Note the sudden shifts on the left. As more data comes in, the ranked list changes suddenly. In our tool, probabilities change smoothly instead. Note that in both views, over time, the high ranks converge before the lower ones do.